Okay, so let's begin with numerical values in public health dentistry. First up, we have the tools of epidemiology, which are rate, ratio, and proportion. Now, what is rate? Rate is any value divided by time. So, let's say the number of people infected by a disease in 1 month is your rate. Okay. Next up, we have ratio, where n is not a part of d. Okay, so what happens is ratio is what? Ratio is something similar to number of boys in a class to number of girls in a class. Those are two different entities. Now similarly, what is proportion? It is n upon d, where n is a part of d. So let's say number of boys in the class to the number of total students in class. That is your proportion. Now next, another important thing is incidence and prevalence. So what happens is incidence is a rate which is a number of new people affected by the disease. That is our incidence. And what is prevalence? Prevalence is the sum total of people affected by the disease. That is new plus old, and it is a proportion, while incidence is a rate. Next up, we have odds ratio, which is used for analysis of case control study. Now, what happens is, in a case control study, we measure the parameters risk factor versus disease. Okay. So the formula is AD divided by BC. It measures the strength of association. If odds ratio is 1, there is no association. If odds ratio is less than 1, it prevents disease, and if it is more than 1, it causes disease. Next up, we have relative risk and attributable risk, both used for analysis of cohort study. Relative risk is the ratio of incidence among exposed divided by incidence among non-exposed, and attributable risk is incidence among exposed minus incidence among non-exposed divided by incidence among exposed into 100. Next up, we have the case fatality rate, CFR, or virulence. It is the number of deaths divided by number of people affected into 100. Next up, we have 4 important parameters: sensitivity, specificity, positive predictive value, and negative predictive value. Now, very important to understand this, we must understand this table, which shows screening test versus disease, positive and negative. We have 4 columns, A, B, C, and D. Now it is important to understand this table, which is screening test versus disease. When A is true positives, that is when screening test is positive and disease is present. D is true negative when screening test is negative and disease is absent. B is false positive when screening test reflects positive but there is no disease. C is false negative when screening test reflects that there is no disease but the disease is present. So very important to remember these formulas. Sensitivity is A upon A plus C, and specificity is D upon D plus B. Both are vertical. Okay. With respect to positive predictive value and negative predictive value, both are horizontal. PPV is A upon A plus B, and NPV is D upon D plus B. Now coming to another important topic of public health, which is biostatistics. To begin with, we have measures of central tendency, which include mean, median, and mode. Next up, we have measures of dispersion or variation, which include range, mean deviation, standard deviation, and coefficient of variance. Now let us have a detailed look as to what these terms imply. To begin with, what is mean? It is the sum of all the observations divided by total number of observations. Next up, we have median. In order to obtain median, first up we have to arrange all the data in either ascending or descending manner. Let's say we have 9 numbers. So what will be our median? The number which is present at the fifth position, that is the center position, whichever will be the data that is present, that is going to be my median. However, let's say that there are 10 numbers, then if I have to calculate the median, then I'll calculate at the fifth position and the sixth position, and I will take the average of it. Next up, another important measure of central tendency is mode. It is nothing but the most frequently occurring value. So what happens is, if there are 10 numbers and let's say a particular number is repeating 3 times, like it is repeating the maximum number of times, then that value is going to be my mode. Next we have with us bimodal distribution, which is present in Hodgkin's lymphoma. The formula is mode is equals to 3 into median minus 2 into mean. Next up we have measures of dispersion. The first thing in it is range. It is the difference between the highest value and the lowest value. Next up we have mean deviation. It is the value which is obtained after dividing, after subtracting value minus the mean. So once again, what is mean deviation? It is each value minus the mean divided by total number of observations, and standard deviation is RMSD, that is the root mean square deviation. Okay, that is, it is the square root of mean deviation. Another important formula is that standard deviation is SR of V, that is SD is SR of V, that is standard deviation is square root of variance. Now what is coefficient of variance? It is standard deviation by mean into 100. It will be better if you just write down these formulas somewhere and revise it frequently, so that whenever you come across numerical questions, you can do it well. Very important numerical diagram asked is normal curve, bell curve or Gaussian distribution curve. Now what happens in this is, mean plus or minus 1 standard deviation is 68%, mean plus or minus 2 standard deviation is 95%, and mean plus or minus 3 standard deviation is 98%. Another frequently asked question is, the value of mean, median and mode in this normal curve is the same and it is equal to 0. The value of standard deviation and variance is the same in this curve and it is 1. Another numerical question is, what is standard error? Standard error is nothing but standard deviation divided by square root of total number of observation, that is SE is SD by square root of N. What is a quartile? Quartile is nothing but 1/4 of a value. And what is percentile? It is value, let's say for an X percentile, the value will be X upon 100 into N, where N is the total number of observation. With respect to biostatistics or public health, a very important term is hypothesis. Hypothesis is nothing but an assumption that, okay, if I use this drug, then this will be the effect. Now there are two types of hypothesis, null hypothesis and alternative hypothesis. Null hypothesis means that there is no association between the drug and the effect. And alternative hypothesis is that there is an association between drug and the effect. And obviously in any thesis or any study, we want to prove the alternative hypothesis to be true. That let's say whatever drug we are inventing, that is effective. That is what we want to build. Another important Viva question is, what are two types of errors in biostatistics? So we have type 1 or alpha error, which is falsely stating alternative hypothesis to be true. Another, we have type 2 or beta error, which is falsely stating null hypothesis to be true. Now we will start with another very important topic in public health, which is fluoride. First up, we have Dean's Modified Fluorosis Index given in 1942. Now it has 6 scales: normal, questionable, very mild, mild, moderate and severe. The values are 0, 0.5, 1, 2, 3 and 4 respectively. Very mild is less than 25% and mild is less than 50%. It will be a good discussion to discuss the normal fluoride levels which are there. So those are as follows. In the outer enamel we have 2200 to 3200 ppm. Dentine we have 200 to 300 ppm. And cementum we have 4500 ppm. In the dental plaque we have 15 to 64 ppm. With respect to mouth rinses, in the ones used daily, we have 225 ppm of fluoride which have a concentration of 0.05%, and those which are used bi-weekly. The fluoride content is 900 ppm in 0.2% fluoride concentration. Next up, we have 1 ppm of fluoride. 1 ppm is 1 mg in 1 liter. The calculation goes as follows. 1 ppm is 1 part per million. So we have 1 gram of fluoride in 1 million parts, which is 1000 mg in 1 million, which means that we have 1 mg in 1000 ml. So we have 1 mg in 1 liter of fluoride. Next up, the fluoride content in different fluoride varnishes is as follows. For Durafat, we have 22,600 ppm, and for Fluor Protector, we have 7,000 ppm. Few more important fluoride numericals are: the most common form of fluoride in dentifrice is sodium monofluorophosphate, which has 900 to 1000 ppm of fluoride. Differences between 3 important fluoride compounds: sodium fluoride, stannous fluoride and APF. We have 2% sodium fluoride, 8% stannous fluoride and 1.23% APF. The percentage ppm is as follows: 9200 ppm for sodium fluoride, 19500 ppm for stannous fluoride and 12300 ppm for APF. Now with respect to pH, we have neutral pH or 7 for sodium fluoride, 2.4 to 2.8 for stannous fluoride and 3 for APF. The Caries reduction percentage is 30%, 32% and 28% respectively. These are the recommended fluoride dosages. These are some important Caries activity tests. We have with us first up Lactobacillus colony count test given by Hadley in 1933. So what he did was he counted the Lactobacillus colony forming units and he divided it into 4 grades. The 4 grades are little, slight, moderate and marked, 0 to 1000, 1000 to 5000, 5000 to 10,000 and more than 10,000. Next we have colorimetric cinders test, which uses bromocresol green dye. Depending on how sooner or later the green color of this dye gets converted to yellow, we have 3 different grades. If the conversion happens, the 3 grades are marked, definite and limited in 24 hours, 48 hours and 72 hours respectively. Next we have salivary reductase test, which uses diazoresorcinol dye. There are 5 different grades: non, slight, moderate, high and extremely conducive based on the color, which is blue, orchid red, red immediately and pink or white. Next we have swab test, which measures the pH. If less than 4.1, indicative of marked caries activity. If more than 4.6, it is indicative of caries inactive.